Hello everyone, my name is Avkash and I just wanted to let you know that this tutorial has taken me over a week, days and night to build something incredible for you. In this end-to-end retail data analytics using Walmart tutorial, you are going to actually use the all 4,600 Walmart locations in US and close by territory, and using this actual data we are going to perform the end-to-end retail data analytics. In this tutorial you are going to build the master customer data for the user profiles, including their family, marital status, income, credit card, vehicle, and various other kinds of information. You will also learn the fundamentals of the data management, like managing the master data, transactional data, as well as the analytical data. You will create the purchase history for 2 years or even more years if you would want. And finally, you will combine all the data, master plus transactional, to generate your analytical data. And based on analytical data, you are going to create the various visualization and analytical graphs and dashboards, all specific to retail data analytics. This tutorial is designed in 6 different phases. Each phase is individual and complete by itself. In the first phase, you are going to build the master data for the user profile, where you are going to create the synthetic but almost realistic user data. We are going to create the user address based on the close proximity of the Walmart stores in all over US. Very interesting aspect of generating the very realistic but synthetic user data. In the phase number 2, you are going to create the products data, and for this we are using the actual product sheet from another supermarket store. In the phase 3, we are creating the stores list, where we are using the actual Walmart stores in all over US to generate our stores master data. In the phase number 4, we are generating our actual purchase history. We are using almost 50,000 of these products, including the 4,500 of these stores, and using the synthetic user data, we generate the n years of the purchase history based on month. These user profiles are scattered all across the United States, including Puerto Rico territory. After 4 phases, when we have our master and transactional data is ready, we include all that thing to help us to build our purchase history. And now, combining master, transactional, and analytical data, we are ready to perform the retail data analytics in phase number 5 and 6. In the phase number 5, we are creating the plotly based maps to show where the stores are and where the purchasers are purchasing their item in their close proximity. And in the phase 6 and the last phase, we are creating the various retail analytical dashboard using the graphs. So combining from phase 1 to phase 6, you are going to get end-to-end retail data analytics experience. In this project, you are going to learn various aspects of data science as well as the Python programming using Pandas, Fakers, matplotlib, Plotly, and various other supporting libraries. If you are excited about the mapping plotting, then this tutorial is going to show you the multi-layer plotting using Plotly and the Pandas dataset. Once this tutorial is complete, it is not the end. This tutorial has lots of data which can be used to build the future projects based on Streamlit, Dask, H2O Wave, and various other Python libraries where you could build the dashboard applications for the retail data analytics. This application can also be extended into a full stack program where backend can be used with Python, Java, and the front end can use the any other popular React framework such as Core UI, Chakra UI, or other frameworks such as Next.js and Angular. So let's get ourselves started. So for any organization or the business, the general data management strategy is quite simple and is almost identical for everybody to start with. You have data, and your initial data is divided into three different kinds of data. One, you have master data, where the key information such as user information, product information, organizational information, all the data which does not change more frequently or stays same for long amount of time goes into the master data. The next one is the transactional data. The transactional data is the data which really happen on day-to-day basis. It means depending on whatever the organizational active frequency. For example, airline, you are seeing that aeroplanes are going to move on daily basis. However, if there is an airline which only fly once in a month, then the transactional frequency for them will be once in a month. They will not have the daily data or hourly data. For example, companies like eBay, where the transactional frequency is in millions in a day. So you can get an idea that what the transactional data, it's all about the activity data depending on the business or the enterprise. The third one is the analytical data. So analytical data is the data which is used to generate the analytics related with the organization. So analytical data will be depending on what your organization is, you aggregate that data. You assimilate that data with other data sources. You combine your master data plus transactional data plus some other data, and then that will become your analytical data. You bring third-party data to improve your analytics. So these three different kinds of data are going to be available in almost every organization or enterprise you are going to work with. In our example, when we are taking the Walmart size supermarket and looking into the retail data analytics, we have to look into this image. For the retail data management, if we look into what are the properties or what kind of data is going to be part of master data, just in nutshell, it could be very big for a Walmart size enterprise. However, for our example, the consumer data, which includes the consumer profile, consumer address locations, and consumer accessories, could be anything. Could be number of vehicles they have, could be number of houses they have, could be number of other articles they have, TV, the kind of TV they watch, the kind of watch they wear, anything which helps a user to identify first and get as much as information about that user, that would be the part of consumer data. But that information does not change frequently. Second is your products data. So depending on a store such as Walmart, you might have hundreds of thousands or maybe few millions SKUs related with your product. So product, item, and the SKUs are two separate but connected things. A phone, iPhone is the iPhone product or the item, but there could be several SKUs related with the iPhone. SKU means that an identifier which can identify an individual product completely, that SKU. So that will be part of products data. However, not all those products are in every store. Some of the products are very local depending on where it is. So the store items data. So as all is going to be part of your master data. For our example, the transactional data will be the purchase history. What items are being purchased by the users in individual items. That's purchase data. And finally, the analytical data. There could be a lot more things could be happening for a enterprise like Walmart, but for us, a consumer purchase history. If we have 1 year worth of purchase history for X amount of people belongs to Y amount of store, store location in the United States, that data is your treasure trove or the source to generating the analytics related with the retail stores such as Walmart. So for example, in this tutorial, we are going to use the 1 year worth of consumer purchase history, and that will be part of our retail data analytics project with Walmart Superstore. So very first step, we are going to create the user profile data, which is going to include the user address data as well as the user accessories data. And in accessories, we are going to use the vehicle. And when we are creating this whole data set, we are going to make sure that data set is, even it's artificial, however, it's correct and identifiable. It means user could be identified based on their geolocation. So let's get ourselves started with the creating the consumer data for the master data records. Here I will be creating a template users first. So let's create the Google Colab. I'm using Google Colab for this project. Here we are creating the consumer, that's our Jupyter notebook, and we need to have the Faker to start with. So because it is not there, so I have to install pip install Faker. Faker is there, so we are importing, and then we need to instantiate. So we could create our object Faker is equal to Faker, and now we have Faker object available. I do have a tutorial which is related with how to use Faker to generate the artificial business data, and that tutorial is available in YouTube, so please visit that tutorial. The tutorial to use Faker is available here, so if you are interested in learning more about Faker, please visit this tutorial. Now I do have a template code which I will be copying and pasting here, because otherwise it's going to take quite a long for me to type. So let's create some user profile details here. For example, here using the Faker profile, you could create the female profile, Audrey Brown. If you would want to create the male profile, lots of male profile related data such as address, birth date, blood group, company, job, a variety of information is already added for that user. However, for our project, we need to create some really very specific user data. So rather than using the profile, we are going to create the user data quite manual, step by step. So here is the data where we are using first name, last name, manual date of birth. So we are controlling the minimum age should be 21, maximum age should be 80. And we are using the datetime library and UUID. So let's import it here. So here we have the first name, male or female we are creating. We are also creating the manual date of birth. So we control the minimum and maximum age. And then based on date of birth, we are generating the total number of days the person has. So number of years that a person age is. So based on that, we could even generate the various other details such as marriage, kids, etc. Then generating the phone number, social security number, and we are creating the profile UUID. So this user profile UUID, like a unique profile ID, and we are also creating the 10 character family ID. So let's import the datetime and UUID from datetime, import datetime, and then we also need to import the UUID. After that, we could run this. So here is a male name, date of birth 56 years, 11 months. So this is the age we have intentionally created for this example. Social security number, phone number, the UUID and the family ID. So this will be the profile related details for our main consumer. That's, we just call it user profile. So we are creating the user profile here. Now we are going to create the job related data. So job specific info, and for that we are going to use the faker job company address. So here the person job, where they are working, and what's the address. So this information can be used for the job specific information for our main user. Next, we are going to create the credit card information. For the credit card, we are still using, we need random. So let's import random. So these are the credit card types available. We are choosing a particular credit card type provider, and based on that we are generating the credit card number based on our choice, because different credit card have different kind of their number, 15 or 16 or 18 digit long, and when this credit card will expire. So for the Visa, this is the number. So this code block is going to generate the user credit card information. In the next step, we are going to create the income group. So that will be, and here we are creating an income group, and just using the random.choice, we are generating the, because this income group can be used later to perform various new purchase record, as well as the analytical history based on a person income. We are also going to use this income to generate a person how many cards they could have. If they are making more money, they can have even more cards. So in the accessories data can be generated even more logical depending on the understanding of a person income in the realistic scenario. Next, let's look into the marital status, and we are going to use the family group single or married. So randomly we will select if this person is married or not. If they are married, then we need to create their wife or spouse profile. In this example, we are using male as a main family person, so the spouse will definitely going to be here female. So here, if the family choice is married, and we can add phone number, if female phone number, their social security number, their UUID, and here in this example, even we are creating the family ID, but in real scenario we are going to pass the primary family owner family ID. So if married, this is the name will be created, and the last name will also going to be matched with the family member name or the main family member name. And we will also going to create this date of birth, which is very close to the primary family person or primary family member. It means maybe 5 years plus minus, just to be more realistic rather than being totally random. We can also say that if married, then we can also use this married status to have the kids, just for being more realistic. So here, depending on marriage, if they are, the person or the family will have 1 to 4 kids. If the kids are greater than 0, because I have used 0, even if you are married does not mean you are going to have kids. So 0 to 4. So here you are going to get if kids group, and if the kids are greater than 0, then for each kid, so for each, so it will be in range here, and then we can generate the male or female. And we also need to make sure that the date of birth for these kids should be at least 18 to 21 years younger than their parents, and that will be the logic we are going to use here for the male and female kids. So that's how you are going to generate the male and female. And this is just the sample understanding of how we are going to generate the data. I have another Jupyter notebook where we are going to create the data in sequence correctly. After that, we are going to use the vehicle data. As we know that the Faker library, the vehicle are available through the community provider. So here is the Faker vehicle. So we would need to install this provider so that we could use it. So for the vehicle data, we are going to install the faker vehicle. And once the faker vehicle is available, then we need to import the vehicle provider, and then after we need to add that provider. So once it is installed, we already have the faker vehicle provider, and then we need to add the vehicle provider for the faker. So now if we use the faker.vehicle, you can see that vehicle related information is available. So if you look into the vehicle object here, you are going to get the pickup, Ford, model, and year. So this is where you could get a very quick the vehicle specific object created for your user. If you would want to create the 2 or more vehicle, you can make this vehicle object call multiple times. This is how you are going to create the vehicle data. Next comes that we need to generate the very realistic the user address data or user location data. To understand location for a user and making it more realistic, we need to make sure that the user location is in US. It means that it must be within the US geo addresses within the longitude and latitude which belongs to US territory. So let's take a look at the Walmart actual store data here. So this is the actual Walmart store data. I have already logged into this website, so I can access this data. This is the actual data. Here you could see that the store name, which location, street address, city, state, zip code, and we also have the store longitude and latitude. So here is the location, but we are interested in this latitude and longitude. So this information is what is going to help us to create the very realistic user address location data. So I already have another tutorial which I created how to visualize the Walmart store locations on the geo map using Plotly. So here is another tutorial which I have created to show Walmart stores visualization in Python using Plotly. And if we look into the GitHub for this tutorial, we can see that we are using Walmart data which we have collected from here, this Walmart data in this example, and using this Walmart data we are generating the maps here. Those maps, they look like similar to here. So you could see that the different Walmart locations in United States, Hawaii, Puerto Rico, and then the density shows that where there are more stores, where are less stores. You can also create the bubble graph, or you can also create the hex map. So this exactly data is used in this Jupyter notebook to create this data. From this Jupyter notebook, you can also create this data set where you can get the collection of all the stores and their location, longitude, latitude, as well as the resolution of longitude and latitude in a single precision. So this is the data set I am really talking about. This is the data set where you have the in every state, in which city, in which zip code, you have longitude and latitude where the exact Walmart store is. And later we are setting this decimal precision to 1, and based on that we are creating the total number of stores, total, and that total density is being rendered in these graph which we have seen in these map images. So this data set will be used by us here in this example so that we could get the exact user record. So I already have saved this data set. This data set we are going to upload here in this content folder. So content, upload. So here is the selected stores data set, and this data set has the records related with all the stores in states and the zip code. So let's use this. So we need to import the pandas. We can say import pandas pd, then df equals pd dot read csv, and we need to provide this selected stores.csv. So for city, state, zip code, longitude and latitude. So 4,653 rows. So that many store information we have related with all the supermarkets in US and territories. So this 6 decimal precision geolocation shows very close proximity data. So as you could see here, that if you have the 6 decimal precision, you are in almost about this range for a geolocation. However, if you have a single precision, you are about 11 kilometer. Technically, 5 digit is about a meter. You are in 2 5-digit numbers proves that they are about a meter distant. So if we make our geolocation up to single digit, it means the address will be created in that 11 kilometer distance. It means we can make sure that based on this particular store location, the new user we are creating, that user exists within the 11 kilometer of the diameter or distance from the store. So we can take this data and we can set its precision. So we need to set the precision equals 1, and then we can use the df dot latitude equals df dot latitude round precision. Same thing we need to do for longitude. Now if we look into our df, the precision is set. So now our df only has the CA related record. If you would want to use the Washington only, then we need to reload this df, otherwise our df does not have any Washington record. So let's reload it again, and next time we use a local. So here df we will use the local. So df local will be the CA related information. If you would want the Washington related information, then df local has the Washington 67 information. So this number will be 1 to 67 as required. So now you have got the idea that how we could select a particular location for the exact Walmart store to create our user profile. So if we would want to select a particular record, we can say df local dot sample. So we will get one single sample. So as you could see here, we are getting the return as a data frame. We do not want the return as a data frame, we just want return as a list. Then we can change it in our result here. So we can say make it to dictionary. So the result will become into the dictionary, and you see that the only problem is that it is taking a record ID and setting its value. We have to change the orientation. So the city will be city, latitude will be latitude rather than this value. So let's fix this, and we need to change the orientation equals record. Now you see that your record is created. So city, Tacoma, this depending on Washington. If we would want to make it CA, now you are getting a California related record. And if you see that this is an array, so if you would want very first record, that will be very first record. So hopefully you can get an idea that this is how we are going to get the location for this exact user where we would want to create our fictitious user profile. So here we are creating the fake street address first, then we are selecting the location from our data set. So we are selecting a one random location. Based on this random location, we are getting the state value, we are getting the zip code. So state is here, zip code is here. Then we are also getting the latitude and longitude. So latitude and longitude is here. So you see that this is what the random location is generated, and here is the state and zip code. Here we haven't printed the longitude and latitude so far. So now we are getting latitude and longitude for given random location. Now we can add the random 5 digits to each of these numbers, so we will get the user location in somewhere in the vicinity there. So here we are creating the random 6-digit float number. So random uniforms is going to create a 6-digit random number here. You see, as randomly 6-digit float number is created, which start from 0.1 to 0.9. So this is a random 6-digit number is being created. Now we just need to add this number to latitude and longitude, but we need to be careful because sometimes latitude and longitudes are negative. So if they are negative, we need to subtract them so they stay negative. So this is the code. So if latitude is greater than 0, then we are adding it, otherwise we are subtracting it. So these are the random 6 digits, and then latitude we are making sure that everything is a 6 decimal digits. Same thing we are doing exactly for longitude, and then we are printing longitude and latitude. So here you could see that this was our starting longitude latitude. This is our new longitude latitude. We do not need to show this line. So this is how we are generating the random longitude and latitude in our data set. Now we can actually show that where this longitude and latitude for our user profile exist in the map, as well as we can also show that how far it is from the actual store location. So let's render that. In order to render that, we need to look into the examples which I have already created earlier. So we can use this plotly specific code. Here I'm importing plotly, and I'm also using the mapbox token. If you do not have mapbox token, or this token does not work, please log into mapbox and get your own token. Then after, I will be creating this scatter plot code. So here is the scatter plot. Now we need to provide the data set data frame where the longitude and latitude is there, and the count. So we really do not need to provide the store count because we know that there are only 2 records here. So let's create the record data. Okay, so first we can use the first value for our store here, this one. So we can say store data equals the latitude is the latitude, longitude is the longitude, and the count is 1. Latitude, longitude, and count. Same thing we have here, and that is the profile data, latitude, longitude, and count is 1. So these are the store data and the profile data. Now we can use this store and profile data store into a data frame, and that data frame we can use here. So all stores, then we can say all stores dot append, and first we have the store data, then we have profile data. So now we can see what is our all stores really look like. And as you could see here, there is a count 1, so there are 2 records available, but again these are the precisions. Okay, now we can convert that to a data frame. pd dot data frame. Now if we look into the all stores, is actually the data frame now. Longitude, latitude, count. Let's call it count, count, count. And these 2 points, as you could see here, they are existing here. The point and point, we can use a different map here. Let's use this hex pin. All stores, longitude, latitude, and it will be the count. It's like here is the 1 point, and here is the another point. So you could see here that the store location is in one location and the user location is, so this distance could be about 11 kilometers. So thus I just wanted to prove you that if we are creating these fake records, we are making sure that they are still valid and they can have a location within the US geo map. Let's create the density map too, or the heat map. Let's use this. And here are the both locations. One is store location, and here is the actual user location. So hopefully that should clarify you that how we are generating the very realistic consumer data for this project. So once we have understood our strategy to generate the consumer data, now we are going to generate the master consumer record, which means that we are going to generate hundreds or maybe thousands of these records for the each location depending on where these stores are. Let's save this. We are going to create another Jupyter notebook. So this is the consumer data. We are creating the another collab and we just call it consumer profile master data. So this will be our master data for this consumer profile. And here in this example, because we have created this single precision data set df here, so we can save this data frame. So df dot to csv stores single precision dot csv. Walmart stores single precision dot csv. So that file is generated and it's available here. So we can use this file in this example whenever we are going to create the master data for our consumers. Let's use this code as a template for us. So here, this is what we really needed. We need to install Faker because there is no Faker here. Let's install it. While it's being installed, we could actually import and use it. So this is our here and Faker equals Faker. So now we have Faker available. So we are almost ready with our base setup. Now, based on this work we have created loosely, now we are going to create much more methodical work here. So again, I will be using the template code to expedite our work. So first we are creating the get age. So you will pass a date of birth. Based on your date of birth, this will return the number of year and month remaining, age and month. Next, we are creating the job info, which we have created job name, job company and job address. So this is the job data. Then we are creating the income group for the user. Then we are creating the credit card info. And this is exactly the same code which we have used earlier. So most of the code which we are using in this master data, we have already tried earlier. I just make them in a function so we could keep calling them as needed. Here is our kid profile, because in our previous example, when we were generating the family, we haven't created that when we want to create the kid, male or female kid profile. So this is a whole function, is generate the kid profile, and it passes the family ID, family name. I'm going to explain more, but this is very quick information that if you want to create male, then it's going to create the first name, date of birth, depending on whatever the mother age is. It should be the less than 18 years of mother age, and minimum age is a 1, and then phone number, social security number for you kids. So that's the kids profile. And here we are creating a function called add kid to family by passing the family name, family ID and mom's date of birth. So this function calls this the kids profile, and it's create the kid profile here. Let's create the male kid profile or female kid profile. So this method, then we are going to create the family, add the user family. Here we are passing the family name, family ID and the age years, so we can figure it out that depending on the main family person age, we need to have the spouse age within the 10 years of that age group. So maximum and minimum age should also be 21, and rest we have already seen here. So this is like a if married. And finally we are defining the user profile, and let me explain everything. This is our main or master function. We set up the profile type. If the profile type is male, then we set up the male. It means that if you can create the female profile too, but just to start with, so we generate the UUID, profile UUID, we generate the family ID, we create the family name, then we create the male or female main family name, then date of birth, we get the age, years and age in months, then we generate a fake phone number, social security number, and then this becomes the family data, all that information. After that, we add the income group and we add income group here. Then we create the job info, then add that job info here. So our JSON is keep getting updated, and job info, everything we have already added here. Then we add the credit card information, and that is also added here. In this sample, I have added the credit card information as the part of main master data. I did not keep it as a separate data set or separate table. After that, we are adding the user family, and I'm just passing the family name, family ID and years. So this add user family method decides whether you need to add single or married. Randomly system decides, this function, whether this person is going to be married or not. If it's married, then it's at the wife or the spouse name here. So it's a female name is created in this example, and it uses the family name and family ID, and age is close to master, and then rest is phone number, social security number and other information. After that, the kids list, and then here if the age is greater than 25, it means the household family person. If their age is more than 25, and user family data, it means they have a wife, means there is a spouse. If this data is not none here, then the kids had to be added into family. So add kid to family, that method call, and randomly 0 to 3 kids are decided. If the kids are more than 0 count randomly, then we add that many kids here, and we randomly select that whether this kid is going to be the male or female. So this is what we use. It means if we select a create user profile here, and we say that we need a male person, and then this is going to return this result for us. And here if we would want to print the family data, user family data, so family is main, second is spouse, and third is kids list. And this is how you could see that depending on family choice. So for the same family, we are getting family, Jack, Angela, date of birth, depending on kids. They might have more kids if we want to know. Print length of kids list, so 1 kid. But if we keep running this, no kid, only person but no spouse. Person, no spouse. Person and 1 kid, no spouse, 2 kids here. So you can get an idea that this method we have created, it generate a whole user data. Now we need to add the vehicle data as well as the user address data next. So let's add the vehicle data here. So we need to do pip install, I do not remember the name, vehicle data, so faker vehicle. Now we could create the vehicle for the users, but in order to generate here, we need to have the family ID, so we can relate this vehicle belong to this family. So here is the create vehicle data. We are passing the family ID, and based on that, it generates the vehicle make, model, category, everything. So this became the vehicle data. So if we just passed a random family ID, it generates the vehicle data. So this is how you will be able to create the vehicle data for a given family. Next, we need to create the exact address or the location data. Remember, we have already saved this WM single precision store. So let me download it locally. Then I will upload it here in this VM, content, upload, dataset is available here. Let's use that. We already have pandas imported. So df equals pd dot read csv. We need to take this. It is our. So after we have read our dataset, let's look into the df. dataset is available. If you would want to filter it, we could actually say that the df is equal to the df, and it has the new fields we just are interested into is state, then we are interested into city, then zip code, then latitude, longitude, df. So we have a state, city, zip code, latitude, longitude. Now based on that, we could write our method which could get the data from this. So get Walmart location by state, let's call it, and we can say I need a data from, for example, New York, and this will be the store equals, and if you look into the store, it should tell us this is the store, East Meadow, that's a location. If we want a data from Washington, that will be Washington. So this method gives a random record related with whatever state you are interested into. Now here comes our master function. So generate user location, we are passing the family ID and state, whatever state we are trying to create here. And rest of the code is very much identical to this code which we have earlier studied it. So I will not re-explain for you. But whole idea is that at the last it generates this location data which has a street address, city, state, zip code, longitude, latitude, and family ID. Once we have this is our method. It takes the state and generate everything. So now we have full skeleton is ready for us to create the master data. So we have already created the user profile data, address data, and accessory. It means the vehicle data. So now let's try to create that data set, combining user profile and the family with the location. So here we have user profile, location data, vehicle data. Everything is going to be created, and if we would want to print this whole thing, we are getting user profile, kids, location, and vehicle. So we are almost getting ready to start generating our data set. Okay, so let's see how many states we have. So we already know that there are 52 states, 50 United States plus Puerto Rico and the other Union Territory states. So here is our master function, user profile records, user address records, user vehicle records. Here we are generating all the states. So these are all the states, but rather than all these states right now, we are generating only 10 records in California, Washington, and Oregon. And as you could see here, these records are 10 records are created, but total 55 profiles are added. It means 30 is a principal or the main profile, and 25 are the kids, including the spouse profile. And if you look into any of these profiles, for example, user profile record, you are going to see that this is just a JSON list. It means we need to convert this to data frames. So all these three profiles, we are converting the data frames. So they became data frame. Now we can look into the user data frame, address data frame, and finally the vehicle data frame. So now you could see that this is the vehicle, all belong to family ID, address belong to family ID, and here is the family ID for whole record where you can get the credit card information. NAN means that's the could be the family where we are not adding the credit card information to the spouse. So that's how you will be able to create the records for all these states. If you would want to create the records for every state, so for example, if I want to create the 100 records for all states, at this point, let's run it. And for every state, it's taking few seconds. So we are running for all 52 states, 100 records right now. 11,000 records are created. And now you can see the user, 11,743. Address will be the total number of unique master of the main profile. So 5200 are the unique main. So in our code, when we are generating the records, we have performed a trick here. If the person is married, then we also add one more vehicle to them. It means if person is married, then they might have two cards. Otherwise, they only have one card. So for that reason, if you look into the total number of user records are 11,743 43, that many user profiles we have. We have 50 to 100 addresses, it means 50 to 100 unique families we have. But we have 78, 85 numbers of card. It means some of the families, they have married, that's why they have cards. It means some of these families will have 2 cards. So once you have this information, now you can build your analytical system top of it, because now you have the user master data. So let's save this, and these 2 Jupyter notebooks will be available also in this project. So Walmart supermarket, so let me push them to the GitHub. Python projects, Walmart supermarket. So that Jupyter notebook is available. Consumer data generation, so this Jupyter notebook is available. Now we will move this Jupyter notebook. So now we have both of these Jupyter notebooks are available in the GitHub repo at Python project Walmart supermarket. Because we have just generated these records, we can also save them, so that if whenever we want to build the analytical system, we can also update it. So we can select all these 3 data sets. So we have all 3 of them. So here it will be .to CSV, user profiles .csv, that use address to user address, let's use the vehicles, and we can look into all these 3: user address, user profile, user vehicle are available. After you have created these files, if you just want to validate their size, you can say ls-lah, and you can pass your folder name. So it's a content, and you can see that these are the files we have just created. It means that these files can be downloaded from here to my local machine, and then from here I can send them to this Python GitHub repo. So here is download. Sometimes the pop-up is blocked, so let's enable the pop-up here. Then we can download vehicle, then we can also download profiles, and then finally we can download addresses. And all these 3 I'm just uploading directly here. So vehicle, edit. So these files which we have just generated are also available. So our most of the data related with this project for the consumer data we have created. In the next step, we are going to work on the products data and the stores data. In this next step, we are going to generate the products data. And to products data, our objective is to look into the Kaggle Instacart market basket analysis project. Here you can get the department, aisles, as well as the products related data. So for this project, you need to sign up with the Kaggle, and once you sign up, you can download the aisles data. You can also download the departments data, and you can also download the products data. So we have aisle, department, and project. We can upload all these 3 data sets to our new collab. So I will be creating a new Google collab, and we call it store products. That's our new collab, and here in this content folder we are uploading all these. So these 3 files which we have downloaded, aisles, departments, and products, are uploaded here, aisles, department, and products. So let's import the pandas pd, and we just call them aisles equals pd.read csv, aisles.csv. Then we have departments equal departments, and finally we have products, and products. Let's see how the aisle data look like. So 134 aisle, and then departments, about 20 departments, and based on that Now we have products. So that many products in which aisle and which department. So because of this product name, aisle and department, we had to get these three different data set. Now we are going to replace this aisle ID with the aisle value and the department ID with the department value. So we have product. So let's work with first. So we can say prod with aisles. So prod with aisles equals. Now we need to merge this. And as we know that the product has the aisle ID and here are the unique aisle ID. So we need to generate a merge strategy in a way where all the IDs in this product replaced with the aisle IDs available here. So we say pd dot merge. Our parent will be the, or master will be the products, and second data set will be the aisles. So that's the aisles. Now what is our join strategy for merge? So we have left join where the keys from the left will be used, right join where the keys will be the right will be used. If we use inner join, it means the union of keys. It means all the keys available in products and aisles. If we use outer join, the intersection, the keys only common in between left and right. So in our case, our join type is inner because the combination of all the keys between the product and the aisles data set, how will be inner, and then the field name will be on equals aisle ID, just to make sure aisle ID and aisle ID, they are correct. We can look into the product with aisles. This will be the product, and now aisle are added and aisle ID is there. Same thing we can do for departments ID. Same strategy we could use. The only thing is now we call it final products, final, and here the left will be the product with aisles, right will be the departments, same strategy, department ID. Hopefully that clarifies you. We have product final. This is our final product data. If we would want to get filter, we do not need these two columns. We can just create a new data frame or we can drop them, whatever option you could choose. I would use columns because I'm not interested in dropping anything. So product finals equals product final of, and then we can select, we need product ID, we need product name, we can use aisle, we can also use the department. That's our final product ID, name, aisle, department, and we can save this. So to CSV products list.csv, here is our products list. We can always check the size of it. You can say ls-lah content. So product list is 3.3 meg. We can download it, and after it's downloaded, I will also upload this to here. So we have products list is also available. This is products list. So product list is also added. It means in our master data, we have completed the consumer. Now we have products data too. Save this Jupyter notebook also to the GitHub repo. So store products. Restore products. So after we have generated the consumer data, our next step is to generate the stores list. For stores list, we are going to look into this Walmart stores data, and as you see here in this data, we have the list of all stores, but there is no ID available. So we will do two things. First, we will strip most of the information from this store data set. We only select that we need longitude, latitude. We will also use the name, and we will also add the custom ID for each store so that we could recognize that store using the custom ID here. So let's create a new Jupyter notebook at Google Colab and use this data set. Please make sure in order to use this Jupyter notebook, you need to download your own Walmart dataset from this data.world website. So I will be creating a new Google Colab here and we call it store master data. Import pandas as PD. I will be uploading this Walmart dataset to this location. So this dataset is already available. So we will use the df equals pandas dot read csv and it will be Walmart. So this dataset, now we have all these 4654 records. Now we will just filter this dataset. So we just need only selected fields here. So we need the name, longitude, latitude. Now we are going to add the UUID for each name. So we could use that UUID as store ID. Now we are going to create the new column called store ID and add the UUID for in that column to be the unique store ID. So here is store ID, df apply UUID. We need to import the UUID here. So import UUID. So now apply df store ID. If we look into the df, so we have a store ID, longitude, latitude, name. We could save this data set and the data set will be our master store data set. So df dot to csv master stores data dot csv. The data is available here, master store data. That's about 389k. Now I will move this master store data from here to upload in this Walmart supermarket repo, so it will be available for everybody. So first download. That's the reason I'm not uploading the full data set. I'm just uploading a really very partial information because that can be used without any problem. Master store data is added. Perfect. So now we have that data also added. So we have generated the stores list data now. And we are also going to save this Jupyter notebook in our GitHub repo. And finally, we have this Jupyter notebook in the repo. In this step, so we are going to create the customer purchase transactional record and that will generate our consumer purchase history. So first we need to create the Jupyter notebook, consumer purchase, and we already have this product list here. We can look this URL, download, copy link address. So this will be our products list source, and we also need the users data. So we also have the users address profile. So here is the address and user profile. So we can select the user address data raw. We can also select the user profile. So these are the source data set we have. Let's import pandas as PD. Now we can create the products equals read CSV products list. We have products available for us. Next we need to have users. So let's use user profile and user address. So users address, here we can see that there are users from every state. So based on this user's data set, if you'd want to count that how many values are in each state, let's do so users add, then we are looking into the state value. So we can say value counts. So here, and if you remember, when we were creating this consumer master data, we have created 100 records for each state. It was here. We have created 100 records for each state. That's why we are getting 100 records for each state. And alternatively, you can also do this group by. So you can say users add dot group by on state, and then you can say I need to get a count too. And that will give you, it's a little dirty way because it changes the column, everything, but that's where you can get a count. So this unnamed column is basically your count column, where this count is. So you have the idea that now there are 100 records for each state. We can filter at this user data set and say just we want to work with only California users. So users add, we can create something called users CA, where you can say users all the addresses, and we can filter them the users address where state is equals to CA, and this users CA will all the records related with CA. So all the 100 records, all the CA. Now we can select whatever family ID we are interested into. So let's create the purchase history there. Then we also need to create the years. So we can say let's use 2020 and 2021, these 2 years. And we can say for year in year, then for month in range, and then we are looking for 12 months. So that's will be our month value. So for every year we are going to get the records for every month. So first day of the month will be the date time year, selected year a month, and last day of the month will be the first day plus whatever the month adds. So that will give us the first day and the last day of the given year and given month. We will select for index and the family in our user CA. So this will be our user CA dot, we need to iterate it, ITE, iterate row, iterate rows, and it's going to give us the family. So we can say family ID will be the family of family ID, but that's where we are gonna get the family ID. So depending on whatever the data frame we are using, we are going to get the family ID. Once we have family ID, now we can randomly select for that month that family can run that many times the shopping to that particular store. So here we can say for I in range, and now we can say random rand range, and we can select this person goes either 1 or goes to 5 times. Random is not defined. Let's import random. So that will give us the random visits for each visit. Now we need to create the random order ID. So here we are creating the random order number. We need faker for that. Let's bring the faker here. We can install faker. So now we have faker available. So that's going to generate the faker number. Next, we need to get the random date in this month. So month start first day of the month and last day of the month. So we can use faker to create the date between. So this is the purchase date, first day of the month and last day of the month. So now we have got a particular date. Then we can create the random numbers of orders. So items in the given order. So we have got 1 to n items this person is going to be purchasing. So it will generate the how many orders we want, and based on this number, now we can use the products data set and we can generate the that many sample based on this number. So our data set is products, so we could say the products dot sample, and then sample size will be this number, and then we can also say for prod index product in, and the result, this will be a data frame. So we could iterate here, iterate rows. So up to here should be clear. Now we just really need to build our basically the shopping cart, because that many orders this person is purchasing. So this will be product index. We have made this selected product and is sample. Now let me use this script. So order info will be order number, purchase date, when we have purchased this, family ID, order total, quantity, we are just using the random value, product ID, product name, and the price, just a random value, something. And that order will be stored into the purchase history. So purchase history dot append, and that order will be inserted here. So that's where you can get an idea here for each family. So we are selecting each family. So we have started this. That will generate the purchase history. If we would want, we could actually add a log here. So it will tell that which month and which year we are. This has completed. Now let's see what is our purchase history look like. This will be our purchase history. And again, it will be a big JSON. So we need to convert this to data frame. So we just call it purchase data frame equals to pd dot data frame purchase history. And here is the purchase history. Order number, there are 29,000 purchase. Which date we have purchased, date and time, which family, total number of orders they bought, total quantity they have bought, in that how many items are in that order, which product they have bought, what was the product name, and the total price they have paid for that. So that should give you an idea. Couple of things we are missing. First, we are not making sure that which particular store they have bought. It means we need to get this location detail for that user so that we could figure it out. So we need to match a particular user is buying the store in their close proximity. So that will be our next step. We would want to attach or connect the stored UUID in this purchase order. We have to use this master store data which we have created earlier. So let's use this master store data and use raw URL. We just create a new cell. We just call it store list equals, this is our path. Now we can read the stores here, equals to pd dot read csv stores list. Now we have stores here. So we know which store ID close to which latitude, longitude. So now what we need is that when we are creating this purchase for that many time, so depending on this family location, wherever their address, we will find the closest available store based on longitude and latitude, and we will select that particular ID here. So for that reason, we need to get the family location and we need longitude and latitude. So that value will be in family. So family database is user CA. So user CA, so we have longitude. So the family location, longitude is the longitude. and then family location latitude will be the, so family location longitude and family location latitude. So they both are available for us. Then we can create a function so we could get the ID here. So we already know this. So inside this, for each time, we need to get the location here. So we can add here supermarket address UUID. So here we can say supermarket UUID equals longitude and latitude. Get closest supermarket, and here we just need to select only for 1 year. So just use only for 2021. Also use for only 1 month. We don't really need for month in range 1, just one time. And we need to add this supermarket UUID here, product ID, supermarket UUID. So once we have this get closest supermarket location, we can implement here. So this will be the family longitude and that will be the family latitude. So let's define, and it's going to return the supermarket. So we just call it supermarket ID. So we have, this is the implementation of this method. So depending on whatever longitude and latitude is going to be get in, that will be able to return the result. So based on our strategy, we are going to get these values trimmed down all the way to single digit, and that's where we are going to match these value single digit with the single digit value of the user location. So this is the family longitude and family latitude. So we are taking the local longitude latitude, and which is basically the rounding to the 1 digit. Then after we are selecting the store based on longitude, which matches at least 1 single digit precision stores, and then same thing we are doing to the latitude, and it's this time we select the selected longitude data frame, and if it is match, then we select the very first record, and based on orientation, and then based on that we get the very first store ID. So that's our method. Only requirement is that right now the stores value is not matched with single precision, because currently if you look into down, the stores values are 6 decimal digits. So we are going to set the precision equals 1, and then we will take the stores dot latitude. So stores latitude will be stores dot latitude round based on precision. Similar to that, the longitude, and if you look into the stores, we have single digit precision. It means that this check will be okay, and this will be our supermarket ID. So that's should be correct, and here we should get our supermarket ID, and we can say if supermarket ID is not none, so this whole thing will generate the purchase history. So if you look into this, run, let's try this. Let's see purchase history, and here you could see that we have that many record, and depending on which store. So now the supermarket UUID is also added here. So one more time, I just wanted to reiterate what we have done. We have just took the family longitude and latitude to single precision, and we have also reduced the store longitude latitude to single precision, and then we just match it equal, because we believe that it should have a match, equal match, and based on that we have selected a single, because it is possible there will be multiple of a store based on single precision. So we just select random one and just take that as our selected a store and select the store ID, and that's what we are using here. So if you would want to generate this for 12 month, we can say it is a 12 month. We can say this is actually for 2020. So 2021, 2020, and here for 12 months. And if we run this thing, it might take a little longer. And back to this. And if we run this thing, 15,000 record. That's where you have the whole supermarket purchase history is created. This purchase history which we have just created, we are going to save this locally, and then we will upload this to our GitHub repo CSV, and the file will be purchase history ca.csv. So this is the purchase history for the California. Let's try to create one more purchase history for a different. So here we have users CA dataset. Let's create the users Washington. So we have users Washington, where the state is Washington. Users Washingtons are here. Everything is Washington. Then we will change it to, yeah, and we can also make a comment here. Please change the as needed. So now we are using the users Washington. Run it. And for the California, we had about 15,000 record. And for the Washington, for 2 years, we have 10,000 record. And again, this is, so we can say purchase df and we call it Washington. So now we have purchase history CA and purchase history Washington for 2 years. So we will download these two data set. Now I will upload them to here. So purchase history CA and purchase history Washington is added. So Walmart supermarket. So we have purchase history CA, purchase history Washington is available. We also So after we have uploaded the purchase history, now we can validate our data management strategy. We have generated profile data, address data, accessories data for the vehicle. We have also the product list, stores list, and then we created the purchase history, or purchase list. So that's pretty much covered the end-to-end scenario of data generation. Our next step will be to use these CSV files which we have created and build our analytical system for the retail use case. So after we have generated our purchase history, now we can create the consumer location as well as the store location, because using the purchase history we have the information where which family bought from which store ID, and then we can use the store ID information from the store list master data to understand which store belongs to which particular location in which state. So all the data we already have stored in our GitHub repo. So we are going to create a new Jupyter notebook and going to build the visualization here. So the objective we have is that we are going to select the California purchase history, and we are also going to look into the California store list and try to zoom into in the map to show that where the store located and close proximity to a store where the families are and how many times they have bought a certain item. So here is our Jupyter notebook. We need to import the Pandas minimum. Other libraries we are going to use as needed. So we need to have the master store data. Here we know that which store ID belongs to which location. So for all 4,655 stores, this is our master store data. Master store location is this. We also need the California purchase history. So this is California purchase history. Purchase California equals pandas dot. So this is our purchase history, and only certain fields we will be interested into, and we are going to work on that. And we also need the store history, all. So here are our all stores. Which location? Longitude, latitude. Here is the supermarket. So what we need is that we need to generate the count, that which family from which store, how many times they have bought items. So let's work on purchase history first and make this data set completely ready. So purchase, we need to get family ID and supermarket ID. So we could select family ID and supermarket ID. At this point, if you look into your purchase CA, that's all you really have. Next step, because there are so many families records, so we need to just generate a count. It means we need to do a group by, and then we need to generate the count. So we could use this data set, and we can say for this data set, we need to do the group by, and we need to select the family IDs and supermarket UUID. So we got this. Then after, we need to use the size. Once you do the group by, you can get the family ID, supermarket UUID, and here is your total. And you look into here for this supermarket, these two families bought, and from this and this family bought from two separate supermarket from close proximity. Now we need to take this data frame and we need to first convert this thing to a data frame. So you could say dot to frame, so that will convert to the data frame. So this became data frame, but we need to add the column, because this column has the total but it does not have the name. So you could say to frame, and you can give the name equals total. So after the total, we can actually reset the index. So reset index, and now everything is set properly. So this will become our final purchase. So we just call it final purchase data frame, and that has which family from which supermarket, how many items they have bought. So now we know that this family from this supermarket, that many times they have bought. One thing is missing right now, that we do not know that this family location. So we need to look into our address data set where the user's address are here, and we need to extract all the longitude and latitude for each family ID. So this became our user address, and we can say df address and user address. So now we have df address available. So here is your purchase df, and here is the family ID, and here is the for family ID we need longitude and latitude. So we need to generate the merge, and left side are the family. So if we will use the family df as a left and do the left join, all the values related with family ID will have longitude and latitude. So we could create pandas dot merge. Left we will use final purchase, right side we will use the df address, then we will use how, which is the left side, and the on will be the family ID. If we use this merge, you will see that all the left side 85 rows which we had here for supermarket total, we also got the supermarket total, we also got the longitude latitude. Now we could take this and filter out whatever fields we are interested. So we could generate, here is the address temp. So this is just an address temp data frame, and this address temp I can just use here. So this is the address temp, and now if we would want to generate the purchase df equals this data frame, and we are interested into family ID, supermarket ID, total, longitude, and the latitude, and that is your purchase data frame. Now, if you would want to generate a map based on that, you could very quickly generate it. So we will generate this map first, then we will bring the store map on top of it. So let's build the map. In order to build the map, we have already used this code earlier, so I won't be explaining a lot. We are importing Plotly Express and using the mapbox token. Let's build this density map. Here our data frame is purchase df. So purchase df is our data frame. Latitude, longitude, we already know these two fields are there. Rather than store count, we are using the total here. So that should be our map. So all the purchase history we already have. Let's try to set this figure layout so we do not have these borders. Update layout. So the margin is the dictionary where bottom is 0, top is 0, left is 0, and right is 0. So this is full map, and then we can also set the height here. Height is equal to 600. That's where your all the purchase here, and then you could actually get an idea about the which family has bought where. So the density really shows that depending on which family bought how many times. So that should give you the step 1 of this tutorial. Let's call it purchase stores visualization. So purchase history, purchase with stores visualization. Save it. Next step, we need to work on our stores. So this was our stores data set. So we know that these stores belongs to everywhere, all 4600. We need to filter these stores only from the California one. We already have this data set where we already know which store belongs to which state, but this data set does not have that information. So we can look into another data set where I think I do have the stores with state geo. So here the list of stores, we know that all the stores with geo information. So let's take this URL, stores with geo equals this. So this is stores with geo, stores geo df equals all these stores with geo. So what we need is that let's use this, and then we can select all these stores from the California CA. If we look into this, all these stores which are related with CA 281 stores. So if we have this, we could actually filter only the required field we are interested into, and we are interested in name, latitude, longitude, finally. So this is our store, longitude, latitude. So let's generate the merge here. So pandas dot merge. Our left will be the stores geo. Our right data frame will be the all stores. So all the keys will be used from this left data set, and name will be the ID we are going to use. So how is going to be use the left, and the on will be the name. And now based on this, we just really need to filter the interested fields here. So we just create this stores temp df is this. You just write it here, and then the stores Viz df, which will be the last one for visualization. We are going to select this store temp and which store and which store ID, longitude, x, and latitude. We just select one of it, and that will be our data set. Now we just need to change these names. So we could say dot columns equals, we just select these names and call them. There you go. That's your stores data set. Now we could visualize these two in our map. Let's select this map. This was our map. This is our density map. So based on this new data stores Viz, we need to add this density map. So we could say the figure dot add, and then we could actually add the density map on top of it. You see, add density map box. It is going to use the latitude from here, longitude from here, and it does not have total. So let's remove this and let's try to build this map. So you could see here that all the red locations are the stores. All the red locations are the stores, and all the previous, these values are purchasers or the consumers. Very nicely that this is the purchaser and here are the stores. These are the stores and this is the purchaser. If you look into here, this is the purchaser and there are the close proximity store. Same thing here and here. So this way you can build your graph or your map to show that where the purchases are and where the stores are. And once you have this detail, you can actually use this detail to even draw more conclusion. You can figure it out using reverse geolocation, the distance between these 2 points, why this person is really going here, or what items they have bought, what particular reason they didn't come close to their store versus they went to this store. So there are so many things can be drawn conclusion analytically based on this kind of analytics with purchaser as well as the stores. We will save this and we will move this Jupyter notebook to our GitHub repo, and the project is Python project. Everything is okay. Few seconds and our notebook is available here. So this image can be updated in a way that we have shown that where the stores are, and these red dots are the stores, and where the purchaser is and how many items they have bought from there, because that resolution is created based on number of items, not the number of visits. You can condense them also. So in this step, our objective was to build a map something like that, and that we were able to build exactly. We have shown that where the blue dots are, where the purchaser are, and where the red dots are, where the actual stores are, and we were able to build this map. So now we can take a look back to our general data management. So master data, transactional data, and analytical data, and this step is all about analytical data. In order to arrive the analytical data, you have to have the master data and transactional data. So we look into all the things we have done in past in this exercise. We have generated the profile data, address, accessories data. We have generated the products and stores, and then purchase. And we created the California as well as the Washington purchase. Based on that, we have created this consumer and closest store analytics, so we could understand where the purchasers or the consumers are coming in those stores. And now our target is to build the real data analytics with the retail use case. So most of these scenarios are hypothetical. However, they are actual for the retail data analytics. For a company such as Walmart, or even a smaller company, even if you have a 10 to 20 store, or not only that, even if you have a single store, you would want to build your retail analytics, you are exactly going to do. Scale will be big or small. Usage criteria could be bigger or small. However, the thought process of analyzing the retail data will be exactly the same. So this is what we are going to do. We are going to look into our source data sets, combine whatever necessary, not all, but whatever is necessary, build the analytical data pipeline, and then we are going to build these analytics. There could be many of them. If you are playing with this data set, you could come up with any particular scenario and search for the data and try to find the answer. I'm just going to give you some of the examples so that you could learn, and then you can explore by yourself. So basically, I'm just going to give you the getting started part with retail data analytics here. So for that reason, I already have this Jupyter notebook created for you. It's complete. Otherwise, it would have taken massive amount of time to build this from start to finish. So this Jupyter notebook is ready. As you could see here, I have already referenced some of the data sets which we have created earlier and saved. So if you are going to look into all of these, this tutorial, previous sections will tell you how we have created each one of them. So you do have all of this data available, and when in need, you reference to your data. So let's import the pandas, and we are also importing the matplotlib because we need to show some graphs. Graphs are way better way to represent the information so that others can understand. Here are the 4 URLs which we are using, and I have named them in a way so they are more intuitive. So first we are looking into the California data frame, which is the purchase history for the California. Here for 15,652 records are telling about 100 families purchase behavior in 1 year. We have created this 1 year data. So it's a 1 year data for the purchase history in 2021. Next, we are using the California data frame, and then we are grouping by based on family ID because we want to understand for each family ID how they have collected this data. So we need to learn this thing a little better. So I'm gonna walk you through piece by piece by piece. So let's start from here. So we are creating this group by which will generate the data frame group by. And once you have that, then you can generate the keys and you can walk through everything. But in this scenario, we want to get the sum of the records for this family ID. So we will process the sum. And based on that, all the unique family and the sum is going to be generated for all the numeric field in your data frame. So you look into here that in this record, we are getting the sum of the price, quantity they have purchased. Order total is not a correct information here. Product ID is not, because even they are two numeric field. The sum is really trying to take all the numeric data, which we are not interested into. So we are taking this data frame and then we are summing it up, and then we are making it to reset index. So reset index will be called, and now this data frame has the total number of index. So it shows the 51 records. 51 families are purchasing variety of items from variety of stores. So here these are the sum values for this data frame. However, still there are so many other fields are available too, correct? We have supermarket, from which supermarket they have bought, what product ID they have bought. So because that's a quantity is really trying to accumulate everything based on family. So first we are going to take this data set, and that's what you are getting here. So we are creating a first data frame. So it's a df1. So if we would want to know for a family that how much money they have spent and how much items they have bought, that record set should be able to help us. Here now we are creating the group by based on each family, how much they have spent and how many items they have bought from different supermarkets. So this is a similar to previous one, but this df2 actually gives us the information for these family from this supermarket and they spend that much money. So you could see here that this last item here, this family spent $16,000 on purchasing 888 items in whole year. Here this data frame shows that this family spent on 2 different stores. These are the number of items they bought from individual stores, and this is the money they have spent. So this data frame gives us little more granularity depending on what you are looking for. If you are looking for total expenditure perspective, this data frame is good. If you are looking into from a store manager perspective or the supermarket management perspective, you can understand where the consumption are from individual family. Now based on that, we are using this df2 supermarket ID and we are creating the bar graphs. It shows that for each supermarket where the total number of purchase happen for family. Okay, so let's run this thing. So here you could see that we are seeing that for supermarket ID, for each supermarket, what was the money spent. But this graph does not have the bottom or the X labels written properly. So here we are making this much more better. Here we are creating this X tick label and we are setting the rotation to 45 degree just to show you that if we try to do that, we do not get detailed information. So it's better to fix this problem by this, where we have changed this graph in a way that we know that which supermarket and how much money was being spent on each supermarket from the families. However, if you would want to check the money spent by the family, then you can look into this data df1, and df1 will give us the details about that how much money is spent by the families. If you are interested to get that, we can actually use this. Here we can select that df1. We want to have the family ID. We can look into our df1. This is the df California, and here is the df1 data frame, and it has df1 family ID and price. It should be total, but I'm not really trying to change anything. So this will be family ID, family ID, family ID, and here will be price of df1, 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 df1. So for families, the money spent total, and that's for the different stores. So hopefully once you have that understanding, now we can go and look into that the relationship, because as of now these IDs, they do not help us, because if you are a store manager, you want to know which store it is, so you can have better understanding of it, correct? So in that scenario, if you would want to look that perspective, we need to look into the store data frame, and here is our store data frame, because it tells us from which store ID, what is the store name, and where store is located. Similar to that, if we look into our expend or the total purchase history, we only have the supermarket ID, but we do not have the supermarket name. So in order to get that thing, we have to get that using joining these two data frame. It means this is our stores data frame, and that is our purchase records, everything. So this will be our requirement. We need to add the supermarket name in this data frame based on this. It means if we are trying to do merge, this will be our left. It means every supermarket UUID which is available in this data frame has to have the supermarket name. So either we could use the CA data frame, or we could also use the smaller like a df1 or df2, but we are just using CA data frame, and rest you could see the left on. So here we are using the left side data frame, because in CA data frame our left side is supermarket ID, which matches with store ID in this stores data frame. So left side is supermarket UUID, right side is the store ID, but our how merge option is left. It means everything from the left keys. So now the CADF has changed. We have added more fields to it, and if you look into here, you can see that store ID is added, which is store supermarket ID, which match with store ID, and the store name, latitude and longitude is available. So this CA data frame is updated now. If you want to fix this thing, you can actually do the reset index here, and it will fix your reset index too, because this result is going to be the data frame. So this is the data frame. And reason we are not doing is that because CADF equals to CADF. So CADF has already been updated. So if we do reset index, it's going to create problem to us. It's just going to merge two more time. So now based on CADF, we are creating the third data frame, but here we are using the family ID and the name, store name. So here you could see the family ID and store name, and here is the total. Rest is useless. This information is not really needed. So just, I'm not trimming the data set right now. So here is the DF3. So if we would want to create the DF3 name and price, because that was our objective, And now you know that each store, which store has no, means nobody purchased from there in that store left side, and rest of the stores, these are the money spent on these stores or people have purchased item. Next, we are using the California data frame and just trimming it out, so we only know the family ID and the name. So that is our DF4. So DF4, here we know that this family went to that many stores. So now we need to count that, okay, which family use which store most of the time. So that's why we are using family count and then reset index. So that will become our DF4. Let's look into this. And that is our DF4. So very quickly you could see here that this family that many times made visit to those stores. If you would want to make this record based on family and this, then you can add this, and I can just show you very quickly that you take this, which is, so right now let's build the DF4 again, and here we are using the DF4 family ID. We can also use the name. As you could see here, that we can see that this family went to two different stores, 146 and 169 quantity count. So combining that, if we look into here, that should be, it was last YZ 350. So that should give you an idea that how you can generate the count as needed for you. So this is the total. Now we are using in DF4. So this is our DF4. We are building the DF4, and here you can get that which family made highest trip, and here we are just trying to keep the family information private because not everybody should have that information. So now we have understood that for family, and here the name, we could, if you want, we can convert that to total, but I'm just trying to make this much more faster for you because hopefully after this whole tutorial you have better understanding of how to play with pandas. Here we are creating another data frame, and now we are using the family ID, how many quantity, and for the product ID. So this is our DF5. Now we know that each family, what kind of products they are buying and how many quantity. So if you would want to get that whole family, that DF5, and if you want to group by, let's run this thing. You can understand that this family, these product IDs, they are buying that many quantity. So if you would want to get the full quantity, you can understand that which family is more interested into what kind of data. Now here another one where we are looking into the family and price. This means total expend. So let's look into this DF6, and here is the for each family, for number of items they have, how much their money they are spending. So you can understand the lowest versus highest here too. This data frame, look into the sum of the this. So whatever DF6 we have done, so this way we can calculate everything. So family and total expend, and here is the value, family and the total money spent. Now we know that in the California, this was the total in 1 year money spent by the shoppers. Now we look into the Washington data frame. So here we are reading the Washington data frame, and this shows the 1 year worth of different families purchasing items in Washington store, and that much money they are spending for each and every item. So we could generate the Washington sum. So now we know that what is the Washington sum, what is the California sum, and if you are working with all 50 stores, you have every store sum, and here you could generate the pie graph to show that how much money being spent by the shoppers in individual stores. So that can be generated for all 52 states or individual store state. You can go as deep as you would want. Because we had only Washington and California data, so I have shown you how you could generate for the Washington and California. Next, we are looking into only a certain family. So if we look into the California data frame, here are several families purchasing various items. So we have randomly selected one family. Just so this is the very second family because they only had a one. So I thought I could get a better family which has more records. So here is a 7 records. So we could choose this family. Let's this, and now you are getting this particular family, all the records. So 356 records for that family where they have spent money on various items. So this data is in family data frame. It means for one single family. Now we are grouping by on order. So let's dissect this piece by piece. So we are grouping by order number, and that will generate the data frame group by. So let me do the size on it. You are going to see here that for this order number, each order here, some order has 5 items, some order has 6 items, some order has 9 items. So for this family, based on this order, it tells that how many items are in each individual orders. Then we are converting that to frame and then setting the total. So now we could use this whole thing, and then we are resetting the index. So that is going to generate us a data frame in each order, how many items people are buying. So that helps you to understand that if based on unique visits, so if we know how many unique orders are here, we already know there are 65 of them. Now you can understand that each time how many items a family is buying. Sometimes a family goes to just buy a very small few items. Sometimes people go to buy once in a month, but they buy bulk of the item. So if you are trying to send the coupons, or you're trying to send your monthly booklet where lots of coupons are there, it's better to send somebody who buy everything in bulk, but they also visit less time. It means they just try to purchase all at once. It means they try to make a very big list and buy everything from one single store. And that's a very common way to look into in retail space. But this is a purchase history for one single family. It may not be that much applicable, but when you're looking into everybody, it does apply. So family order count, this is the family order count data set. Now we can visualize that. So I already have that function written. So you could manipulate it depending on your need, but this, now you know that for each order, items are being purchased. But again, this is the random data. But if some family is doing that way, after 1 year, 2 year worth of their purchase history, you can start seeing a pattern, because we all live in pattern day to day. Whole day we follow a certain pattern. So using data science, you can very quickly identify those patterns and then cultivate the information top of it. So based on family data frame, we can group by order, take this, explain it, then we can come back here. So as you see here, we take the family data frame. So we group by, then sum, and then reset index. So now we know that how much money in each order they have spent. So that's where the pricing relate is sum. So now we can look into that for each order, that much money they have spent. So here, how many items they have bought. Here, we know how much money they have spent. And that's how you could really understand, because these are the 1 or 2 items. If we try to match this graph, and you could see that these are the places where less money was spent. So that's orders and the money spent with them. Now we are using the DF6. Let's go look into what is DF6, because we may not remember. This is our DF6. So family, the items they have spent. So these are 15,000 record. So each record represent to one item they have bought and the total money they have paid. So we are looking into the sum of that. So now as you could see that out of these 51 family, these are the total money has spent here. Okay, now what we want to do is that this is the money a family spent in 1 year. Next, we need to figure it out that based on the money spent by the family, and we already have their income group information. Remember, one of the exercise we have done here, which really generate their income range or their income group. So if we read that data frame, we could very quickly figure it out that depending on how much their yearly income is, what percent they really spend. So for that reason, we are reading this profile URL, and in this profile URL, we are filtering the family ID and the income group. So now you know that which family is part of which group. But remember, this data frame is for everybody. So there are kids, there is a spouse, everybody. So what we need to do, some of these people, they are not in income group because the spouse, kids, they do not come into here. So we are removing the duplicate records, and we are also removing all the NANs. So once we clean this whole data set, our final profile looks like this. So there are the family IDs and their respective income groups. Once we have that information, now we look into the family sum DF. So this was our family sum DF. So family ID and the price. So this is our left side. So for every sum DF, we need to get from profile DF here the family ID and the income group, because family ID is common between these two, and family sum DF is our left side. So we are using the left merge. And here you have now for each family, the money they have spent, they belong to this income group. So now we have income group. We also have the family purchase history. It means we can build a graph which can generate the stack graph. So we can understand bottom side is how much money they make, top how much money they spend. Data frame also has a built-in stacked bar where you can pass the data and then it will build something for you. So it may not be that much good even if you try to beautify it. So I have another code which builds a graph for you. So let me build this, then I will explain you. So this code is actually build a stack bar for each family ID. So the blue part shows that what kind of income group they are, and the top part shows that how much money they have spent. So there is not too much resolution because this is random data, but if you are working with actual family data, you will have a very good understanding. Some families spend very high, some families spend very low. So here is the first, we are adding the income group. Second, we are adding the price, and the bottom we are keeping the income group. So these two lines are important. Rest is just the orientation and everything I have created for that. And because the income groups are all the way to 300,000, that's why some of these families are in income group 300,000. And then top of it is their spend yearly based on this data set. Next, we are reading the user profile. So here is the profile DF, and then after we are looking into the marital status. So we want to understand that based on married or unmarried, who are these people spending, because that's we understand they are spending that much money based on their income status, that we need to understand that they are spending based on married or unmarried status. So we are reading this data frame again, removing all the NH duplicates, etc. So we are building this data frame where we have family ID, income group, and their marital status. Based on that, we merge again exact same thing, and now our new data set will have even the married and single information here. So everything we already saw so far, and now we also have a column which shows marital status here. Now what we are trying to do is that based on marital status, we are adding a new column called color. And here is just a lambda function. What it does, it takes if the marital status is single, make it red, otherwise make it yellow. Family total income. Oh, I didn't run this. After I ran the color column, so here you can see married, yellow, single is red. I should have opposite. Married is red, single is yellow. So we can do it. If single, make it yellow, otherwise red. We corrected our mistake. So married is red, single is yellow. And now in the graph, what we have done is that we have set the color. It's a very simple graph what we have built earlier here. Only thing what we are doing here is that in this income group, when we are rendering this graph, we are saying that whenever we are rendering the income group, set a color to it. And color is not based on just a color name. We are setting the color based on the value available in the column. And then we have already set up the color here. So this is what only one change we are adding. Now you will see it shows that red are the married family is expense and the yellow is the single family. So that gives you conceptually that how deep you could go in the retail industry to understand how different families really spend. Now we are going to look into several others because there are so many things we could do, and based on our need, I'm just trying to give you some of these retail analytics tips. This is our California data frame purchase history, and here we are creating the popular product. So we are looking into the product ID and product name. So these are the popular product, and reason I have just created a filtered version so we could accumulate, we could count them, sum them together as needed. So these are the product ID and this is the product name which is being purchased again and again because our data set is based on every item purchased. So there are 15,652 records for all the items. So here we are grouping based on product name, sizing them, which gives us a total, and then convert that to frame. And I will actually, this is a very good thing to show you. So if we are here, it gives the product name, these are the product, and the count. There must be multiple counts too, but this is just a product. Now we say we want to make it frame, so to frame. Now it became a data frame, and here you see the 0 value is basically the total. So when you add this thing, it make that data frame and name is there. Then when you say you want to change this reset index, then this whole thing become a much better looking your data frame with the index, fields, and their column names. So here, once we got this thing, we can sort it. So we are sorting here on total and ascending is false. So if we try to check this thing, that really gives us, so if we look into this, you could see here that based on popular product, so there are some of the product sold 5 times, some of the product sold 4, and then rest. But again, if you have thousands and millions of these records, so you have a better resolution. Now we are filtering all the records which are more than 2. It means 5, 4, 3. We are not keeping everything here. Let me just make one first. So everything you have 2 and above, which is like a 2043 record. And if we try to build a bar graph for that, here is a one big check to see. Here you see that figure size is 200. So we are rendering 2043 record in the graph. They may not be fit properly. So this is the graph you are seeing for 2043, but because I have changed this figure size to 200, so if you double click on it, it's actually going to be bigger for you, and then you can actually see record because the resolution is very simple, 5432, so it's not really very informative. But sometimes when you have to build a graph, something like that, you could use this trick. So this is depending on what resolution you would want in your data set. So after we have built this graph, our next item is to show that where this top product is being sold, or maybe top few products being sold. We will select only top here. So we want to put in the map that this product is sold in these stores. So let's work on that. So here is our data frame for the California purchase, everything. And here is our popular product based on that. So what we are trying to do is that we are filtering the California store to get the product ID. So we are filtering the California all purchase for this record. So we have got a list of these 5 stores where this particular product was sold. Now we are taking this data frame and as a left, and we are adding the store ID here. So now we have to create the data frame final top df, which has a supermarket ID, order total. So we have order total here, product name, we have name, and we have latitude x, latitude and longitude x. So we can choose latitude x and longitude x. So that will be our filtered. It's name x, sorry. So let's make it name x. So now we can rename this. So columns equals, we call name x to name, latitude x to latitude, and longitude x to, and then we could see the final. So everything is properly named here. Now using the plotly, we are showing in the map that where these stores exist. So this code we have already used so many times. So plotly we are using express and the map box token. And here is our density map, which shows that these stores here order 7 came, from here order 8 2 orders came, here the order 4, and here the order 9. So these are the different items which we have bought. So this shows that for our data set where the particular the highest selling items are being sold in the state. So based on our analytical behavior, we have seen some of the scenario, but sky is the limit. You can come up with whatever scenario based on your data set in question and find the answers by manipulating with your data set. So before we complete this tutorial, let's save it and let's push this to GitHub. Walmart. So purchase analytics, this Jupyter notebook is available in Walmart supermarket. So if you would want to work on this workbook and you want to extend this to even other retail analytics questions, all this data is going to be very helpful for you. So that's pretty much cover our retail analytics section from this tutorial. So in this project, we have created various kinds of data, and we have also created the several very informative visualizations, including the graphs. So if somebody would want to extend this project and build several other applications top of it, that is very easily possible. The first example could be that using Streamlit, Dask, H2O Wave, or other similar applications, this whole data set can be used to create the full scale retail analytics dashboard. The retail analytics dashboard can help other users to plug in their data and use the same analytical capabilities what we have covered in this tutorial. The other example could be to create the full stack application where the backend can have the Python, Java, Node.js, or any applicable programming language. In the front end can use the React.js, AngularJS, Next.js, or any other compatible JavaScript based framework, and the backend can provide all that data slicing and dicing capabilities so that UI can have very beautiful retail data analytics app. Because we have used plotly, means the mapping capabilities, and we have also used the matplotlib to show various graphs, then the dashboard is going to be very beautiful and informative, showing the geo information in the maps as well as the analytical details related with shopping history and stores, etc. in the graphical, or depending on which graph library you would want to use, you can create really very beautiful and informative graphs. So there could be several possible applications can be created on top of this data set, as well as the details, analytical details we have added in this project. I'm also going to create at least 1 or 2 applications as my time permit to show the extensibility of this project. And if you are interested in creating any of these extensible project top of this project, I would be very happy to assist you. Please reach out to me with your objective, what you would want to do, and I will give you whatever help you need so that you could build the extension on top of this tutorial. Finalize this tutorial, let's spend few minutes to recap what we have covered. We started our tutorial by understanding the general data management to make sure that we understand the master data, transactional data, and the analytical data and the differences among them. we spend next 3 phases out of total 6 phases to generate the consumer data, products data, and the store list data. So those 3 things we have covered in first 3 phases. After that, we spend our time to generate the purchase history. And while we were creating all that data, we made sure that even when we are creating artificial data, is still the sanctity of the data is still itself is looks almost real. The various fields within the data, they are created very logically, so they are very near to the actual data set. Finally, in the phase 5 and 6, once we have all the data available, whether it's purchase history data, master data, stores data, product data, everything else, we wanted to combine all of this data in phase 5 and 6. So phase 5, where we have created the user as well as the store proximity map, where we find out that which users are purchasing items from which store in their close proximity. So we build that project or that particular step very clearly. And then in the last step, we have performed various kinds of analytics related with the data we have collected in overall tutorial. And there was several examples we completed with our analytical capabilities related with retail analytics. So that's all we had in this tutorial. This tutorial can be extended to various other projects as I just explained previously. So if you are interested in helping me to extend this project, please definitely reach out to me. I would be very happy to help you. That's all I had in this tutorial. I hope you have enjoyed. I really spent almost a week to build this tutorial for you. So if you like it, please subscribe it, share it, and help me. Once again, thank you so much for your time. I do appreciate it kindly, and I'm going to look forward to see you in my next tutorial. Until then, thank you.